So in this video, I'm going to quickly just introduce rotational kinetic energy. So as you may or may not know, we have really three basic types of motion of a rigid body. You have translational motion, rotational motion, and a combination of that motion. Here's an example of something that is simply just translating. Here's an example of something that's just simply rotating at one spot. And here's an example of something that is actually rotating and translating. If you were to compare both of these objects, do you think that they would have the same kinetic energy? I hope you would say no. Actually, the one on the bottom has more energy because it's both translating and rotating. So in this video, I want to just talk about really specifically rotational energy. Because we've already learned about translating motion, what we're looking at now is rotational energy. All right, so rolling, by the way, as you can see down here, is an example of both a combination of both translating and rotating. All right, so moving down in the notes, you'll see I've introduced rotational kinetic energy. Here you can see that we've talked about the translational kinetic energy. So when something is just moving to the right, it only has translational kinetic energy, and that's calculated by using the formula 1/2 mass times velocity squared. Now when something rotates, right, we end up with something called rotational energy, and that rotational energy is given by 1/2 I omega squared. I stands for the rotational inertia, all right, and omega is the angular velocity measured in radians per second. And you could kind of show that these come out to be that. If you look at 1/2 I and then replace, say, V with R omega and square that, you'll end up with basically 1/2 m r squared omega squared. And you hopefully know that if for a point mass, say something that's just rotating, that is really equivalent to the rotational inertia, which is 1/2 I omega squared. So the example above is just to calculate that kinetic energy, it's going to be 1/2 mv squared. But the example on the bottom here, to calculate its kinetic energy, it's actually going to be 1/2 mv squared plus 1/2 I omega squared. Right? So this example below has actually more kinetic energy.